to buy. And in that case, the project life will be the life of the equipment, and that may very well be different between different equipments, right? All right, so now let's look at the situation where we have to choose which equipment we are going to buy. So let's say again you have equipment A, B, and C. Now for equipment, to characterize an equipment, you will basically need three things. The cost of the equipment, let's just call it P. So P is the cost. And let's say this is 10,000, 15,000, and 22,000. Okay? And then of course there will be the yearly operating cost, YOC. Okay? So in that case you can see both are negative, right? You don't make any money on the equipment, because what you make is already there into the profitability of the project, and you're assuming that this equipment, all the equipment do the job. So whichever equipment you choose, it will not affect the profitability of the plant. You'll still make the same amount of money. So the YOC, let's say, is 2, 3, let's just say 4, 3, 1. Okay, or actually, let's try 2. And N, which is the equipment life, is let's say 5 years, 5 years, and 10 years. Okay? All right, so we have three choices for equipment, A, B, or C. The purchase price is 10, 15, 22. The yearly operating cost is 432, and the number of years it will operate is 5, 5, and 10. Okay, and you have to decide which project to choose. So how do you do that? So first think about comparing A and B, because that's actually relatively simple. It's simple because they both have same lives, so it's very simple to calculate it. How would you compare A and B?
You'll have to buy a second one.
Yes, yeah, you can certainly do that, but without any money. So yeah, after 5 years are over, you can buy the next one. But you have to do that for both A and B. So what will you compute for this? That will tell you which one to buy. Sorry? No, you can never just add numbers spent at different points in time. You can never do that. But what is it that we have you can think of this as a project. NPV, very good. Just calculate NPV, right? Will you go for higher NPV or lower NPV? Oh, you're spending money. Right? Low. Right? Or higher if you think of them as negative numbers, you want to go with less negative. Either way, to compare A and B is easy. You just go with the lower NPV, which represents in this case the net amount you have to pay in the 5 years, right? Does it make sense? Okay. But how do you compare then B and C? You can't do that because other project lives are different. So what do?
You can
Sorry?
say 2 of A, 2B.
You can say this, you can say that, okay, I'm going to do analysis over 10 years, right? But that's still a little bit tricky. So yeah, you could say at 5 years, you buy an equipment, you buy an equipment, and at 5 years you buy another one, and at 10 years you do analysis, right? You can do that. Now that will become tricky if, let's say, this was 9 years, right? You could still do that, but then how would you do it? How long will you have to do this analysis? 45 years, right? You can still do it, but let's think of an easier way to figure out the same problem. So we could certainly do this saying, okay, we're going to buy 9 of these and 5 of this, and still calculate NPV for the entire investment, and then go with the smaller, yeah?
So an NPV where you buy one at 5 years, you buy a second one afterwards for the next 4 years, compare it to see.
No, you can't do that because the life of this is 5, so you can never do it for 4 years. So let me actually show you an interesting way of figuring this out. Now I should tell you that what I'm going to describe now is in principle no different than the previous approach of doing analysis over 45 years. In fact, that method is called, the book says these are 3 different methods, but you will see in the end it's really all the same method. But let me first describe a very clever, in some sense a very clever way of doing it. So let's say this is your timeline. Okay? So you can tell yourself that, you know what? I'm going to figure out how much money I need to put in a bank at time t equal to 0 to pay for these equipments in perpetuity. What it means is that, so let's say that amount is called capitalized cost. So CC, capitalized cost, is how much money do I need to put the money in the bank? And let me explain to you what it means. So first, let's forget about the YOC. Let's say the YOC was 0. Okay? Then, if this is the capitalized cost, you right away have to spend P to buy the equipment, right? So the amount you're left with is how much? CC minus P, right? Now, and if you don't have any YOC, then this will start growing. Now, after n number of years, how much do you want? How much do you want this money to be? Assume no inflation.
Cost of buying.
Sorry,
The cost of buying.
not just buying, because I mean it was always back to the cost of buying plus, right? Because you still want to go down and come back up, right? So after n years, you wanted to go back to CC, so that you go down by P. Again, it grows, and basically this is the amount of money in the bank. And so you can see, for infinite years, you can just buy. Make sense? Everybody understands this idea? Okay, good. Now let's see, we also want to take into account YOC. So now we also have to spend YOC each year. Now what do we do? So simple way of saying it is, you know what we can do? This YOC that we are spending each year, we can convert that to the principal value and add that to time 0. Right? So we subtract the P, right? But then we also subtract the principal value of this annuity. Make sense? Yes? I see a lot of blank faces. So let me just do it, and maybe that will make more sense after I've done with it. So let's start with CC, right? Subtract P, and minus subtract YOC, yearly operating cost, except you have to calculate the principal value of that. So you do YOC, 1 plus I, to the power n, minus 1, divided by R. So this is the amount of money you have left in the bank. Right? And now you can grow this for n years. So this should then be equal to how much? CC, very good. Using this equation, you can calculate CC. Does it make sense?
Can you explain then why it's equals CC?
Because CC is the, so again, what we are doing is we're basically trying to figure out how much money we need in the bank, right? So this is let's say this is the amount of money we need in the bank, right? We don't know it. We need to calculate this number, but we have that. So with this, we pay for buying, right? We have this remaining amount. This is like saying this will take care of the maintenance for the next 10 years, right? So when this is gone, I don't have to worry about maintenance anymore. It's like setting a separate account for it. This is the remaining distance, but this will start growing. After n years, I'll have to do exactly the same thing. So it better be at CC. So again, I can subtract the two terms and again to grow to record the cycle. So it has to end up at the same point where it was this, so that the cycle can repeat in perpetuity. Right? Yeah.
For the yearly operating cost, is that supposed to be like the value?
Oh, I'm sorry, I missed a factor.
Yeah.
I missed 1 plus I to the power n. Excellent, yeah. It should be the principal value, not the future value. So I missed 1 plus I to the power n.
So where is CC on that graph? The P has me confused.
Sorry?
The P up top has me confused.
So
where's
CC, this total is a CC.
Okay, that
This
makes
is
more
CC.
sense. Sorry, that makes more sense.
And a part of that is P. So let's say this is P.
Right.
Let's say this is let's say YOC, the contribution from YOC, except that it's the principal value of the YOC. And this is the rest. So now this will grow. Right? It will come down, it will grow. Does this make sense now? So this arrow is YOC. Yeah.
So why is it growing?
Sorry, why is it what?
Why is it growing?
Because of interest.
Okay, so interest, you grow it until it gets to like a CC, and then you pay the.
Because after n years, it's again time to make a payment. Because the equipment is not working anymore, so you have to buy a new one.
Okay.
Because the equipment life is only n years, right? Let's just say this is n. So after n years, you have to again make a payment, unfortunately.
Okay.
Right?
Okay.
Yeah.
So in our problem, we having given everything but this capitalized cost,
Yeah. We
and
are.
that's what we solve for, and whichever one's the greatest capitalized cost is the worst equipment to have.
Exactly. Yeah. So I mean, capitalized cost is just a construct we have developed to figure out which one is most profitable. You will never actually deposit money in a bank to do this, right? So capitalized cost is just a way of analyzing profitability. Just like we had NPV, DCF/ROR, capitalized cost is a way that we can figure out which equipment in some sense is going to cost the least money. Okay?